All right, so here we have Bunny deposits 1,000 into her savings account at the beginning of each year. So a deposit of 1,000 and it's at the beginning of each year for 10 years. This went on for 10 years, starting at time 0. So to have that, I'm going to draw a line this way. This is time, this is at 0, and then at the beginning, we have 1,000 naira put in, and it goes on for up to 10 years. Now, Clyde makes a single deposit of 10,000 into his savings account at time N. Now, we don't know if N is between 0 to 10 or after the 10 years. We're not sure. One thing that we know is that Bunny deposited this for 10, went on for 10 years, while we have Clyde who deposited at time N. So Clyde makes a simple deposit of 10,000 into his savings account at time N. Bunny's account earned an annual effective interest rate of 5%. So I'm going to see Bunny here. I have Bunny here. And then R is equal to 5%. So Bunny's account earns an annual effective interest rate of 5%. Clyde's account earns an annual interest rate of 6%. So that of Clyde is going to be 6%. So at what time? So we have at time n plus 10. So at this time, the balances in the two accounts are equal. So now let's observe this now. We can see that at time n plus 10, the balances in the two accounts are actually equal. So now let's see what happens. When we calculate this properly, we're going to see that we have n plus 10. So this goes, n plus 10 is after this 10 years, I believe. Of course, it's going to be after this 10 years. So we have this somewhere, n plus 10. So at this point here, the balances in the two accounts are equal. But then take a look at what happens. We have, so now when Bonnie kept on making that deposit, made that deposit up to this point, and then it stops. But then the money grows. So in other words, for another n years. So this is time n plus 10. So we have another n years here that was added to this. So let's see what is in Bonnie's account. The balance in Bonnie's account at this point, 10. So that's for us to do that, we're going to simply say 1,000 times, and this is going to be S10 and 5%. Now, what type of annuity is this? Payments are usually made at the beginning. So this is going to be annuity due. So this is the balance in Bunny's account at time 10. This is the future balance in Bunny's account at time 10. But then this money grows for another n years to make up the n plus 10. So we are going to look at the growth factor, which is going to be the balance we have there, 1 plus 5% and raised to power n. So this is the growth of the money at this point here. Now, the balance is this at time 10. Then for it to grow another n years, we have to multiply it with this growth factor. And so we have 1 plus 5% raised to power n. So this is the balance in Bonnie's account. Now let's see, what's the balance in Clyde's account? Now take a look at it. Clyde made the deposit at time n. So his balance at time n plus 10 simply means that from time n to time n plus 10, Clyde's money grew for 10 years because he made the deposit at this time, but then we are looking at the balance at time n plus 10. So I'm going to say, okay, this money was made was deposited at time n. So the growth is going to be in 10 years. So I'm going to say that the balance in client's account is going to be 10,000 plus 1 plus 6%. That's into 1 plus 6% raised to the power of 10. So understanding these two here, we can see this is Bonnie's account. First, I calculated what is the future balance in Bonnie's account at time 10, and I have this. Then, taking it up to time n plus 10, that simply means that the money will grow for another n years. So that's why I have 1 plus 5% raised to the power n, multiplying it with the current balance at time 10. While for client's account, the deposit of 10,000 was made at time n. So the growth of the money to time n plus 10 simply connotes that the money grew for 10 years. So the question says that at this time, n plus 10, the balances in the two accounts are equal. So that simply means I'm going to say 1,000 with the S and then 10 here. And we know that this is annuity due times 1 plus 5% raised to power n, and this is actually equal to 10,000 into 1 plus 6% and raised to power 10. So when we resolve this, what are we going to have? You can see I have 1,000 here, I have 10,000 here. So I strongly believe that, of course, 1,000 dividing both sides with 1,000, this will leave me with 10. So we are going to have, so I'm going to bring this here since I can tell what this value is for this value. So I'm going to bring the whole of this down here. So I'm going to have 1.05 raised to power n. I hope you don't have a problem with that because 5% is 0.05. When I add it to 1, it becomes 1.05 equal to 10,000 into 1.06 raised to the power of 10 over 1,000 and then s here, and this is 10, 5%. So when you see this, resolving the value here, I have the whole of this. Now let me make it look a little bit. So I know that let me give it a different color so it can my face. So I know that the whole of this goes with part of this, and I'm left with 10 here. Now resolving what I have here, 10 times 1.06 raised to power 10, putting it in a particular side, and then finding this value here, what I'm gonna have when I resolve this. So let me go ahead and do that to say, this 5, this, and compute. So I have, okay, and that'll be times 1.05 raised to the power of n. So when I resolve this entirely and then take the natural log of both sides. So I have to take the natural log of both sides. So let's see how I'm going to do that. When I take the natural log here, I'm going to have n with the natural log of 1.05 equal to the natural log of the whole of this. This is 10 with the 1.06 raised to power 10 over then this value, and this is 10 and this is 5. So when I resolve that, at the end of the day, bringing this down here, resolving this value here, I'm finding the natural log, and then dividing with the whole of this, I'm going to have n to be equal to 6.24 years. 6.24 years. So that gives me the value of n. So you can see this is quite simple, knowing that bonus account grows, that is 1,000 each year for the next 10 years. So we decide to find the balance in bonus account at this point, and then to look at it an extra n years. And that's why we multiply with this. Then for Clyde, the payment was made at time n. We don't really know actually, but from what I see here, we can't tell if the n is around here or it is after that. But one thing we know that at time n plus 10, the balance in both accounts are equal. So let's say we made the payment at time n, and then the money will grow for 10 years to make up the n plus 10. That's why we multiply this with this factor here, and so we have that. So at time n plus 10, both balance in the account are equal, and that's why we equated this. And when we resolve, and I was able to come to this. So that's it. It's quite exciting to have you. Don't forget to subscribe to my YouTube channel. I'm still going to be dropping more videos, calculating more questions, and I hope you're having fun. So subscribe so that anytime I upload a video, you are going to be the first to get a notification of that. Thank you very much. Bye.